So the integration technique that uses partial fractions is what we're looking at next. So the types of integrals we are going to look at are integrals that are rational functions, a polynomial divided by a polynomial. Now remember, if you're faced with an integral, the first question you ask, will a use substitution help? If a use substitution will simplify this integral, then do that. But in all of these cases where we use partial fractions, a use substitution will not work. So in this first video, I'm just talking about some background. If you are familiar with partial fractions and what they are and how to get to them, you can go straight to the examples, which will be in the second video. But let's just look at some background here. If I look at partial fractions, if I look at this first integral, when we talk about partial fractions, what we're saying is, can we write that as the sum of two fractions? Now, here I've already taken it apart. If I look at these two fractions, you know, if I add two fractions together, I find a common denominator, x minus 3, x plus 1 in this case. And my numerator will then be 3 times x plus 1 plus 2 times x minus 3. So then if I simplify it, my numerator will be 3x plus 2x, which is 5x, and then 3 minus 6, which is minus 3. Your denominator you don't have to multiply out, but if you multiply out, you get x squared minus 3x plus x, so it's minus 2x minus 3. So if I go to the previous one, the first integral we saw, we are asked to integrate this rational function that I have here. And if I look at what we've got here, I can write that as a sum of those two fractions. And we are able to integrate them much easier because the integral of 3 over x minus 3 is just ln of x minus 3. So we can integrate this portions where we can't easily integrate this. So from the second video, we're going to look at how to get from here to there and how to integrate. But we just want to lay some background here. If you look at the second example, our common denominator is going to be x minus 1 squared times x plus 4. If I add those three terms together, it'll be 5 times x plus 4 minus 1 times, there's a x minus 1 and a x plus 4 plus 1 times the x minus 1 squared. But what I want you, and that you can further simplify, we're not worried about that at the moment. What I want you to notice is if I have a denominator where there's a term that's repeated, I can have both of these types. So the denominator of one of my partial fractions can be x minus 1 squared and another one can be x minus 1. So just be aware that if I've got a repeated factor in the denominator, there's versions that look like this. All right, some other things to denote. If I, in this case, have got a quadratic that's irreducible in my denominator. So if I had to add those together, same technique, x minus 5, x squared plus 1. I've got a quadratic that's irreducible. So this will have the possibility of having a linear function in the numerator. And we will see examples like that soon. So I'm not interested at the moment in adding these fractions together. I just want you to notice what they look like if they're taken apart. So this will be 2 times x squared plus 1 plus 3x plus 1 times x minus 5, which you can simplify. But take note, it is still a proper fraction if I've got a square in my denominator and a linear function in the top. And this last one is just to show you that sometimes we can get some ugly numbers as numerators, but we treat them exactly the same. If we're going to add those two together, x minus 1, x plus 1, I will just get a half times x plus 1 minus a half times x minus 1. And that's easy to simplify. That will end up giving us 1 over x minus 1 times x plus 1. So if I'm given this integral in partial fractions, it looks like that. So our aim today with partial fractions is to see how to get it from this right-hand side to the left-hand side. And that I will show you from the second video. Now, one technique you need to just be aware of as well is that of long division. So with partial fractions, what we will see from the next videos is we use the technique of partial fractions when I've got a proper fraction. Now, what does that mean? That means the degree of my numerator is less than the degree of my denominator. In this case, it's an improper fraction. I've got two polynomials, but the degree of the numerator is more than that of the denominator. So we will have to start with long division. So here's a quick crash course on long division. I want to divide x squared plus 3x minus 1 into the numerator, which is 2x cubed. I'm leaving a space because there's no x squared term, minus 4x plus 5. Now, the process of long division consists of 3 steps. You divide, then you multiply, then you subtract, and you repeat these steps as many times as necessary. So let me show you. 2x cubed divided by x squared. So that's the first division. Just the first term divided by the first term. And that gives you 2x. We've divided. Now we multiply. What do we multiply? Whatever I wrote down now, the 2x, I multiply with everything over here. So it's going to be 2x times x squared is 2x cubed. 3x times 2x is 6x squared. Minus 1 times 2x is minus 2x. I've done my multiplication. Next step is to subtract. What do I subtract? Everything I wrote now, I subtract from what is above it. So when we subtract that, 2x cubed minus 2x cubed is 0. 0 minus 6x squared is then minus 6x squared. Minus 4x minus minus 2x means minus 4x plus 2x, which gives you minus 4x. And this plus 5, I've got nothing to subtract from that. All right, now I've done my subtraction. Now I start again with division. I divide again because minus 6x squared, I can still divide by x squared and get a proper polynomial out of there. So I've got minus 6. All right, now I multiply. X squared times minus 6 is minus 6x squared. 3x times minus 6 is minus 18x. Minus 1 times minus 6 is plus 6. I've multiplied, now I subtract. 0 minus 4x plus 18x, or minus minus 18x. Oh, sorry, there's a mistake there. That's 2. There we go, minus 2. Minus 2x plus 18x is 16x. And 5 minus 6 is minus 1. So if I had to write this fraction, I can rewrite it as this 2x minus 6 plus my remainder is 16x minus 1 divided by my denominator, which is x squared plus 3x minus 1. So what we're going to do, if we've got an improper fraction, meaning the degree of the numerator is more than that of the denominator, we're going to first do long division and rewrite it like this. And then this last part, we're going to use partial fractions to write it as partial fractions. All right, this next one, those degrees are the same. We have to do long division again, but it's going to be a quicker long division. X squared plus 3, I'm dividing into 4x squared minus 2x plus 5. So 4x squared divided by x squared gives me 4. I multiply, I get 4x squared plus 12x, or plus 12. I subtract, I get 0. Minus 2x minus 0 is minus 2x. 5 minus 12 is minus 7. I'm finished dividing because x squared is bigger than x. So I can rewrite that as 4 plus minus 2x minus 7 over x squared plus 3. You can also put the minus in the front and then take it out as a common factor there. But long division is another technique you'll need to know in order to do partial fractions. So what we're going to do from the second video, we're going to look at examples of how to integrate rational functions by using partial fractions.